Okay, hello everyone. So we have a MATHCOUNTS chapter on spring question. Okay, so this was 29. So the area of the rectangle is 32, and the least possible integer perimeter of the rectangle. Okay, this is the key point that we need to make. So it's just asking this least number that would be integer, but that's going to be perimeter, which means the side doesn't have to be. So some people maybe go with that. Okay, so this is a rectangle. Okay, so we can just kind of find something. So the area is 32. So you can just say, okay, if that's the case, to find the smallest number, the size has to be close to each other. We're making like a square, which is not possible with 32. So you can go with, okay, 8 and 4, or like 8 is this guy and 4 this guy. That's 12. And if you double that, that's 24. So it looks like 24 might be the answer, but it doesn't really ask us to find the integer sideline. It just says integer perimeter. So it's a sideline shouldn't be really the integer. And if I say, let's say this question was one of the first questions, maybe it's better to go with 24 because that's simple enough. But this was 29, so which is why I need to question that. 24 is something achievable as integer, but maybe there is something smaller than that as well. Okay, let's actually see if that's possible. So one more thing, if you have a rectangle, if you like to find the perimeter as the smallest, then that rectangle has to be a square. So there is a really nice way to prove it, but for now, I don't want to do that. So I just want to make a common sense. Let's make this guy 64. So let's say the area is this guy is 64. So you can have this area of 64. I just choose just because I will like to get the a square, and the sides line heights like try to be the same number. So if this is the area, so you could have 1 times 64 from there. So the perimeter will be like 164 and double that number. So it is going to be 2 times 65, which is 130, which is a big number. And if I do this 2 times 32, then the perimeter will be 232, which is 34, and 68, which is, as you see, smaller than this. And then if you do with maybe 4 and 16, so that should be 2 times 2, 16, that's 20, that's 40. As you see, the numbers are getting smaller and smaller when the numbers are getting close to each other. So if I just go with 8 and 8, okay, so that will be 2 times 8 plus 8, which is 16, 32. So you see, when the numbers are close to each other, the perimeter was the smallest. And then if you just increase one of those, like I just increase the first number, decrease the second. So I can go with now 16 and 4. And it will see that will be same as this guy, which is going to be 16 and 4, which is 20, that's 40. So as you see, this guy is the smallest number. So as I said, whenever you are looking for the smallest perimeter of a rectangle, that rectangle has to be square. This is just one way for us to convince ourselves, okay? But anyway, so that wasn't 64, it was a 32. Okay, so now I'm gonna say if this guy and if this guy is equal to each other, then we are gonna get the smallest perimeter, right? So if you use a pi tag, so you will get a square will be 32 squared, right? And I can just say, actually, no, I'm not sure why I'm doing this way. So the area is 32, which means a times a is equal to 32. So a squared is that guy. So a has to be, if you take a square root, so that will be 4 root 2. Okay, so the perimeter will be 4 times of this, which is 16 root 2. So at this point, you can either go with like remembering the value of the root 2, because that's a really common number. So it's good to remember that's 1.4 approximately. And if you do remember this, you can just, okay, multiply 16 by 1.4, you can get actually a close integer, so which might be the case. But if you don't remember, so you probably want to square this guy. So if I square this guy, okay, so that will be 16 squared, 256, and times root 2 squared is just 2. So 512, right? And I just like to see what other two perfect squares close to this guy. So 20 squared is 400, which is smaller than that. 21 probably 441, which is also smaller. But if I do 22 squared, that is 484, right? And you can just multiply if you don't remember. And if you try 23 squared, that will be 5 529, right? Okay, so 529. As you see, so the number that we got as the perimeter is just closer to 529 than it's 484, which means this guy is really close to 23, because when we square, you got 512. 512 is closer to 529, which has to be closer to 23 for this number. So then from there, you can say, okay, the answer is just 23, because that is the closed integer to the perimeter. So why we can't really say this, right? Because it doesn't really have to be size integer. So it could be anything. It could be a real number, maybe some complex number either. So which is we don't really know. But if you are not convinced with 23, then I will actually kind of do a bit more work for us to kind of convince that part. So what I'm gonna do to prove that, to show that. So if that's the smallest number, so that means I'm gonna call these are B. Okay, so A times B was 32. 2 times A plus B is 23 based on my reasoning, right? And I'm trying to find the sides just to see if that's achievable, okay? And if you just replace maybe a substitution, we have a system. So that would be 2 times 32 over A, right? So 32 over A is B. Oh, actually, so yeah, B is equal to 32 over A. So I need to replace with that B, right? So that was A plus B. So 32 over A equals 23. So you may divide by 2. So that should be A plus 32 over A equals 23 over 2. And I may multiply both sides by A, and then I can multiply by 2 as well. So if I multiply this by 2A, so that should be 2A squared. If I multiply this by 2A, A's will cancel, you get 64. If you multiply by 2A, 2's will cancel, you got 23A. And from there, so you got 2A squared minus 23A plus 64. So at this point, you may use a quadratic formula or complete square if you really want to find those A and B's. And A's actually, so A's will be just the solution. And then as soon as you have the A's, you can find the B's and multiply those to see if that's the case. But instead of doing those, I can use my Vieta. If you look at these, sum of the solution is just C over A, which is 32, which is actually A plus B. I mean, A plus A, like two different A values. And the product was that, so A times B, which is 32. And the sum is minus B over A, which is 23 over 2, which was actually the case that we had, right? So we said the A plus, like the sum of the roots 23 over 2, which is we got right here. So that is actually proving that one more way as well. So again, if you like to use a quadratic formula, that's okay. But I hope that makes more sense why that is achievable. But anyway, that was my answer. So no, the answer is 23 for number 29. I'll see you next time.